Okay, guys, so after doing this lab, you can see where we left off with the first video of what we were doing is we had 50 grams of water in our calorimeter, and we had an initial mass of 6 grams and an initial temperature of 17 grams, okay? I was supposed to have this be red for you so you can see that. Anyway, so after doing the lab, okay, so that the marshmallows started burning, and as we know, when we burn things, they release heat, light, um, and so that heat started to leave the marshmallow, and it started to go into the water. Okay, and so when it did, that temperature of the water is going to increase. That's the same thing we've been doing for the last couple of weeks, right? So these are our new results. So after the marshmallow is completely burned, put it back on the digital scale, we saw that it only weighed 0.3 grams now. Okay, or had the mass of 0.3 grams. Okay, and our temperature went up to 36 degrees. Okay, so now let's start looking at the analysis portion, what we want to do next. So first step of the analysis says you'll need to determine the heat lost by the food when it was burned, right? Because we know it's going to release that energy, so it's losing that heat. That's why it says lost by the food. So first step is we need to determine the mass of the water in the calorimeter. We already have that, 50 grams. Then it says determine the change in the temperature in the water. Okay, so that's T1 or T2 minus T1. And then it says using the information above, determine the calories of heat gained by the water. Okay, so this is the same equation we've been working with all week. So let's look at what we have. We're trying to find heat, okay, and we know that that's equal to the mass of our water, which is 50 grams, okay, times our change in temperature, which was we started out at 36 we started out at 17 and went up to 36. That's a difference of 19 degrees Celsius. Okay, so it increased by 19 degrees. Okay, and then we multiply that by the specific heat of water, which is 1. Okay, so when we do that, then we get, let me pull out my calculator here. So we have 50 times 19, which gives us 950. Okay, so 950 calories. Okay, 950 calories worth of energy went into our water. So now it says determine the heat lost by our food. Okay, so again it says remember the heat lost is equal to the heat gained. Well, we just found the heat gained. That energy that heated up the water had to come from somewhere. Where did it come from? It came from our food. So that food released 950 calories worth of energy. Okay, so now we go down to our next step. Okay, whoopa. So it says, okay, now we need to put this into food calories. So in the video yesterday, we talked about, okay, these food calories are just slightly different because one food calorie equals 1,000 calories like we've been talking about in science. Okay, so in order to convert our calories that we just calculated, the 950 calories that we just found, into food calories, we need to divide that by 1,000. Okay, so we should have 950 divided by 1,000. Okay, and the cool trick is we can just use our scientific notation, move our decimal place 3 places. So 1, 2, 3. So we ended up with 0.95 food calories or kilocalories. Okay, with the big C. Okay, we just found how many food calories were released by that food. Okay, then last it says, okay, we need to divide the number of kilocalories. Okay, that's this. There's a nice little arrow for you. In step 1 by the mass of the food sample that we just did. Now, this is important. I wish I would have had this on the same slide. But using the food container, divide the number of calories per serving in gram to attain the theoretical calories per gram. Now, what we need to realize is that the amount of food that we burned is the difference in our starting mass and our ending mass. So if we go back up to our data table, we started with 6 grams and we ended with 3 grams, 0.3 grams. So that means we actually burned 0.3 grams worth of that food. Okay. And so we're gonna actually divide that by 0.3, which is the difference between these two. Okay. And when we do that, we do 0.95 divided by our 0.3 grams. We end up getting 3.16 calories per gram. Okay. So I'll write that down. So 3.16 calories, whoa, per gram. Okay. So now as we look through this next portion, it's asking us, okay, let's look at that at the food container. What does the food say we should have? So we need to compare the number of calories per gram or per serving that we should get from our food. What do we notice? Okay, are they the same? Are they close? What do we think the largest source of error was? Then when we get down to the synthesis questions, it says, okay, what does it mean when we say energy is stored in food, right? So what are we actually talking about there? And then in terms of biomass, so living mass, right? What are plants doing, right? In the field all summer long. Why do they grow? What are they doing in making that we then consume? Okay. And then it says this is just something you're going to have to look up. Describe a carbohydrate in terms of its elemental ratios. So carbohydrates are carbon, hydrogen, oxygen. So we can kind of punch something like this into Google, right? And it's going to tell us because the carbohydrates exist in a specific ratio of carbon, hydrogen, and oxygen all the time. So kind of interesting stuff. So do your best with that. Let me know if you have any questions.